Hello, Algebra, and welcome to Lesson 7.7, the final lesson of Topic 7, covering factoring special cases. And when we talk about special cases, we are referring back to, I think it was Section 7.4, I want to say, or 7.3. Let me take a look real fast. Lesson 7.4. Lesson 7.3 on multiplying special cases. So this is very much linked to Lesson 7.3. And again, if you remember what that was all about what are called perfect squares. So this lesson is all about recognition. If you can recognize, again, it makes your problems a little less difficult for you. Okay, so let's see how good our recognition is. So what is the factored form of a perfect square trinomial, right? A perfect square trinomial. So here's our trinomial. X squared plus 14x plus 49. So what we mean by a perfect square trinomial is we mean something that can be written as the same exact parenthesis twice, which means that you are going to be able to write it as that parenthesis squared. Okay? Now, when you do this, the last sign has to be positive. If the last sign is not positive, it's not going to be a perfect square trinomial. But then to figure out the sign that goes in the parenthesis, we look here. Because that b has a positive, at least we know it's going to be a something plus something squared. Okay. So now, here's how you're going to think about this, right? This is the expanded version of that perfect square trinomial, right? You have to think about this formula right here. A squared plus 2ab plus b squared. Or, if it was a minus sign, a squared minus 2ab plus b squared. But how does this apply to our trinomial up there? Well, let's take a look here. So a squared, well, that's just x squared, right? So I'm going to use parentheses. So obviously x is our a value, right? X squared. So then plus 2ab. So if you divide 14 by 2, you get 7, right? Plus 7. We already know that a is x. So then b must be what's left over to make 14. Well, 14 divided by 2 is 7. b is 7. That's how you get your 14x. And then we just figured out that b is 7, so 7 squared. This is how we just kind of broke down this trinomial into this perfect square trinomial form. And now we just go backwards, right? Now we just do a plus b squared. A is x plus b is 7 squared. And you're done. And you're done. And again, this is that because you could write it as x plus 7 times x plus 7. 7 times 7 is 49. 7 plus 7 is 4. Okay, let's try the next one. Okay, what is the factored form of this perfect square trinomial? All right, so the last problem did not have an a value. This one has an a value, so I would look for a GCF first, right? So the smallest number is 9, so that's 1 and 9, or 3 and 3. 9 does not go into 30. 3 goes into 30, but 3 does not go into 25, so there's no numbers. There's no x here with 25, so there's no x, so there's no GCF, so okay. Now, if you can recognize that 9 is a perfect square, and 25 is a perfect square, I think you have an idea that this might be a perfect square trinomial, right? Now this time, your b term is a minus sign, so when you're answering this, it's going to be something minus something squared, okay? So now let's take a look here. All right, so 9, right? 9 is 3 squared. X squared is x squared, so your a value is going to be 3x squared, okay? Minus, now it's 2ab. Well, I already know a is 3x. So this is 2 times 3x, that's 6x. So what else do I need to make this a 30x? Well, 6 times 30, I'm sorry, the 30 divided by 6 is 5. B has to be a 5. And we should know that because what is the square root of 25? What squared gives you 25? 5 squared. So really, you could do this part last. If you find this part and you find this part, then that part goes in there. And that's a check, right? Because this is 30x. And now in your parentheses, if you want to do 2, it'd be 3x minus 5, 3x minus 5. But the goal is to write this as 3x minus 5 squared. And there you go. Great. All right, let's do one more of these involving some geometry, right? Gotta love some geometry, right? It's what you gotta take next year. All right, so it says Sasha has a tech store and needs cylindrical containers to package her voice-activated. So all of your Alexas, right? Here we go. A packaging company makes 2 different cylindrical containers, right? Cylinder, right? Both are 3 inches high. The volume information is given for each type. Determine the radius. So we need to find the radius of each and how much greater is the radius of one than the other. Okay. So first of all, volume, right? Volume of a cylinder. Volume of a cylinder is equal to pi r squared h. So a cylinder is a pop can. The radius, the r, is going to be for the circle, and then the height is the height of the can, like this. So there's your r, there's your h. And again, remember, pi is just pi. Really, pi is not going to matter, because if you look here, there's pi there, there's pi there, there's pi there. It's just going to cancel. So you should enjoy that, right? You should love that pi is everywhere. Okay, so let's plug in this volume into this formula. So we're going to have volume 1 is equal to pi times 3x squared plus 30x plus 75. Now, first of all, right, we should take a look and see, okay, I have a trinomial inside this parenthesis. I need to look for a GCF. And there is one, right? Because look, 3. 1 and 3, right? 3 goes into 30, 3 goes into 75. There is a GCF of 3. Now, x cannot be divided out, okay, because there's no x here. So this is actually going to be 3 pi. I'm taking the 3 and putting out in front. And now divide all these by 3. That'd be x squared plus 10x plus 25. So that's important, right? That is very, very, very important. And now, is what's inside here a perfect square trinomial? Well, it is positive. X squared is a perfect square. 25 is a perfect square. I think it's going to be. All right, so now watch this, right? So what is going to be your a value? Well, your a value is going to be x, because that's x squared. What's your b value? Is going to be 5 squared. And now, what is 2 times x times 5? 2 times x times 5 is 10x. So we're good. So this is going to be 3 pi times x plus 5 squared. That is your volume 1. And if you take a look at how that compares, okay, to the volume formula, pi r squared h, right? Pi is pi. We're going to be 3 is h. So your r squared is x plus 5 squared. So for the first can, the radius is going to be x plus 5. For this first shape, that radius is x plus 5. Okay, so now what about the second can, right? The second thing. So volume 2 is 3 pi x squared. There's no factoring to do. How does that compare to pi r squared h? Well, pi is pi. The height is 3. So your r squared is x squared. So your radius is x. So this radius is just x. So there's the radius of these two. So it'd be x plus 5 inches, x inches. And how much greater is the one than the other? Well, the one has the plus 5. So the one is 5 inches greater. So again, when it comes to your geometry applications, right, when you're looking for these squares, right, think perfect square trinomial. All right, cool. All right, so this is the end of this video. We got one more video coming up talking about the difference of squares. So stay tuned.